Welcome to Session 5. A Pythagorean triple is a set of three whole number side lengths that satisfies the theorem. Recognizing a few common triples can turn a long calculator problem into a quick answer. Recognition is a shortcut, not a guess. So we will also verify and scale triples correctly. Take 5, 12, and 13. 5 squared is 25. 12 squared is 144. Their sum is 169, which is 13 squared. Because the equality is exact, these side lengths make a right triangle, and 13 is the hypotenuse. Any common multiple of a triple is also a triple. Double 3, 4, 5, and you get 6, 8, 10. Triple it, and you get 9, 12, 15. The scale factor must apply to all three sides. Changing only one length destroys the triangle shape and the Pythagorean relationship. Suppose a triangle has a leg 20 and hypotenuse 25. Divide both by 5 to see 4 and 5 from the 3, 4, 5 pattern. The missing base value is 3, so scale it back by 5. The missing leg is 15. Scaling down can make a familiar triple easier to spot. The numbers 10, 24, and 26 may not be on your memorized list. Test them. 10 squared plus 24 squared is 100 plus 576, or 676. That equals 26 squared. The set is a triple. 5, 12, 13 doubled. Not every right triangle has whole number sides. Legs 2 and 3 produce root 13, not another integer. If no pattern appears, use the theorem normally. Memorized triples should save time when they fit. They should never replace a calculation when the numbers do not match. A right triangle has legs 16 and 30. Both are twice 8 and 15, so use the 8, 15, 17 triple scaled by 2. The hypotenuse is 34. A quick square check confirms that 256 plus 900 equals 1,156, or 34 squared. You can recognize, scale, and verify the most useful Pythagorean triples. Next, we turn diagrams and word problems into reliable right triangle models. Continue at www.bridgetoexam.com.